second last problem, the resistance of galvanometer is 50.0 ohms and reads full scale deflection with current of 2.0 milliampere. Convert this galvanometer into voltmeter, reading is 200 volt. First of all, given data, and from this statement the resistance of galvanometer is equal to Rg and that's equal to 50.0 ohms. Furthermore, full scale deflection of current is I and that's equal to 2.0 milliampere, which is equal to 2.0 into 10 to the power minus 3 ampere. Voltage to be measured is equal to capital V and that's equal to 200 volts. I have to find series high resistance, I mean RH. So let's choose suitable formula according to this given data, and from here I see this one is suitable for me because RH is unknown, V is known, Ig is also known and Rg is also known. So let's use this formula and calculate RH. Formula RH is equal to V divided by Ig minus Rg. Values: voltage is 200 divided by Ig, I mean current, 2.0 into 10 to the power minus 3 minus Rg, which is 15.0. Well, when I divide 200 by 2.0 into 10 to the power minus 3, I get 10,000 minus 50.0. Additionally, when I subtract this term, I get 99950 ohms. So that is high resistance when I convert galvanometer into voltmeter. Let's move to next question. I mean to question number 10, which is little tricky or lengthy. Last question, which is little tricky as well as lengthy. The resistance of a galvanometer coil is 10.00 ohms and reads. The resistance of galvanometer coil is 10.00 ohms and reads full scale with a current of 1.0 milliampere. What should be the value of resistance R1, R2 and R3 to convert this galvanometer into multi-range ammeter of 100, 10.0 and 1.0 ampere as shown in figure. This is a figure galvanometer, this is shunt resistance and this is current. My demand is to convert this galvanometer into ammeter and calculate this resistance, I mean shunt resistance. So let's find given data from this statement. Galvanometer, resistance of galvanometer, which is Rg and 10.0 ohms. Current scale full deflection is equal to 1.0 milliampere or 1.0 into 10 to the power minus 3 ampere. Current ranges, I mean I1, I2 and I3. This is I1, I2 and I3. These are my given data. And my demand is to find shunt resistance. If I see, this is formula for shunt resistance. So let's use this formula and find shunt resistance for R1, R2 and R3. First of all, consider this question and calculate shunt resistance. I mean R1. Formula is Rs Ig Rg divided by I minus Ig. Ig, which is equal to 1.0 into 10 to the power minus 3 multiply with Rg, which is 10 divided by I is 100. This is my current. 100 minus Ig, 1.0 into 10 to the power minus 3. Well, after calculation, I get R1 0.0001 ohms. This is value of shunt resistance according to this portion, I mean when apply 100 ampere. Similarly, consider this portion and calculate value of shunt resistance for R2, I mean when apply 10 ampere. Well, now consider this region for calculation of shunt resistance, I mean when apply 10 ampere. Same formula, Rs is equal to Ig Rg divided by I minus Ig. Ig, which is same, 1.0 into 10 to the power minus 3, multiply with Rg. Rg is also same, 10 divided by I. Now I is 10 ampere. Then minus Ig, which is 1.0 into 10 to the power minus 3. Similarly, after calculation, I get 0.001 ohms. So this is value of shunt resistance when convert this galvanometer into the ammeter. Similarly, you can calculate value of shunt resistance for R3. Just change value of I mean instead of 10, write 1. And the last one is homework for you, shunt resistance when apply 1 ampere current, and write your answer in comment section. See you in next lecture with another topic. Have a nice time. Bye.